Hello, students. You're welcome to today's class. Our topic for today is stages of program development. If you can recall, in the previous class, we learned about system development, of which one of the stages of development life cycle were emphasized on program coding, program debugging, and program emphasized on basic coding in our previous class. And now, similarly, that program or that coding is what is being um, expanded or exemplified in this particular model because before a system is being developed, a program needs to be written. This now leads to where we'll talk about the stages involved in program development, and we're going to be describing each of those stages. Also, we'll be learning about how to interpret and how to draw a program development life cycle. Now, moving away from there, we'll talk about the stages of a program development life cycle. Either you call it program development life cycle or you call it program development. Now, under the stages of program development life cycle, we have program definition or analysis, algorithm design, flow charting, we have DEX checking, program coding, program compilation, program testing, program debugging, program documentation. There are some books that you may likely not see program compilation. And there are some books you will see, but you would not see program definition or you will not see program analysis. All in all, I brought them to make it 9 stages. Now, the very first stage, we have program definition or problem definition or analysis. At this stage, it involves identifying the programming problem and then defining the problem to be solved. Are you here? You want to write a program. Your program, first of all, must be defined. What is the purpose of your program and why are you doing your program? Now, how well now do you identify your program? There are two ways. You must know the program requirements and know the program specification. Under program requirements, what programming language would run on that particular program? Is it Java? Is it Java? Java is also a programming language. Or is it Python? Python is also a programming language. Or is it HTML? You know, HTML is an embed of PHP. Is it HTML that you want to use? You are trying to design a website. Is it HTML, or is it PHP? Is it PHP you actually want to use? Now, all this is for you to know, okay, which particular programming language am I going to make use of in order to write this program? Or is it program requirement or specification? Now, that one talks about, okay, what would the program do? Is it a business accounting management system that you are trying to write? Now, this time around, you are properly defining the program. Is it a business accounting management system that you want to design? Or is it a student management system? Which one? Or is it a class management system? Is it a teachers management system? Is it a staff management system? Or is it a management system in general? Or is it a university management system that will encompass all areas, all bodies of the university setting? You remember, I think one of the classes, one of your project talks about choice of university management system. Now, this particular permanent management system can actually help out in you actualizing that goals. And if you are watching this video, you have to take your time to look at it. Also, questions to ask. Now, what are the questions you can ask when you are doing a definition stage? What are those questions you ask yourself? Now, you remember I said the definition stage. What are you doing there? You are identifying the programming problem and then defining the problem to be solved. What are the things you are doing? You ask yourself, what is the system? What system are you trying to design? How is it working? How is it going to work? Is it a gaming system? How do you want the characters in the games to work? Who are the users? Are the users for adults or for children, or are they for both? Or what is the problem? What is the problem that you feel will not make this program work? Those problems are problems that you on your own should solve. Then who will use it? Who is going to use it? Now, obviously, you are not designing a program for it for you to use by yourself. Who is going to use the program? You should know all of these are normally stated clearly. Also, the second stage, you have algorithm design stage. If you can recall, algorithm, they are step-by-step process in solving a problem. Also, if you are writing a a program, you must have an algorithm. Algorithm should be your number one goal. Without an algorithm, you are bound to make errors. Algorithm helps you for documentation. It helps you to know step by step in order not to miss it. There are lots of ways in which you are writing algorithm. Is it maths that you are solving and you have issues in solving the maths? You must follow stages. You must follow step by step stages in actually solving that problem. Now, you should know that the algorithm stage is an instruction which are to be performed at different stages. It must be performed at different stages. There are in simple English language. Now, you are not, yes, simple English language, yes. You can actually use your own language depending on the one you know. And one keyword is, we call it strategy. Strategy. Um, your algorithm is a sign that you have a strategy to make your program to flow and to function properly Also, we have the third stage, flow charting. Last time we talked about flowchart. What's a flowchart? I told you a flowchart is the diagrammatical representation of an algorithm. Are you through writing an algorithm and you tell yourself you actually want to design a flowchart? Yeah. Firstly, you must design your flowchart. Flowchart has different symbols. One of the symbols here is the over symbol. Now, what does the over symbol does is a point where either you start the flow chart or you end the flow chart. Things that can be written in an over symbol is a start, or is a begin, or is end, or is a stop. It is very important that before you start any flowchart diagram, you must begin with this symbol. Next is the parallelogram. Remember the sequence of writing a program. You have the IPO, input, output, input processing and output. This is your input. What are you doing? Are you trying to input values? This is the input. You must input value, input this, input that. Or are you outputting? You make use of the parallelogram. You make use of the parallelogram. It is very, very important that you make use of the parallelogram in imputing. Also, we also have the processing. Remember the P in IPO, the processing. Are you through with imputing and now you want it to perform the operation? You make use of the processing. Or to further explain processing is the if you are doing 2 plus 2, meaning the 2 plus 2 will be in the processing because that's where the actual work is being done. 2 plus 2. Also, we have the decision. Now, in writing a program, there must be decisions. If this is that, if she is a male, if he is a male, I beg your pardon, if he is a male, then it should be in this side. If otherwise, the person is a female, and if the person is a female, it means the person is in the other side. So, in taking decisions during writing your or drawing your flowcharts, you make use of that distinction sign. Next is the arrow symbol. The arrow symbol simply links a particular flowchart diagram to another. If you want to link from one how the program is being passed from the initial, which is the start symbol, down to the end. So it tells you the direction of flow. Next, on the stages, we have desk checking. Now, under desk checking, it's a process of you vetting your flow chart. Now, have you written your flowchart and you want to confirm if the flowchart is correct or it is wrong? You vet it. How do you vet? You put in real values. You put in real values. In a couple of seconds, you'll be seeing what I mean by inputting real values. Now, you are checking if the flowchart is actually correct. If it's actually correct, and we call it dex checking. We call it dex checking. It enables you to locate and correct as many errors as you can. Now, a very good example of dex checking is what you have here on your screen. Now, if you see this program, obviously is a program that is finding the average of two numbers. So we all know, yes, begin the input num1, input num2, the sum, you have to first sum before you have num1 plus num2. You take your average divided by 2, yes. Now, if you take closely, you will see that in doing dex checking, you will put in values. Your num1, they called it 3. Your num2, they call it 7. Add both of them together, giving you 10 in the sum. Divide it by 5 to give you 2 as your answer to output the average of this number. Now, you can try it with any other number. That's what happens during dex checking. Dex checking. Now, in normal program, you call it dry running. Okay, next, after we talk about dex checking, the next is program coding. Program coding. What is program coding? This is the process of translating a flowchart into a computer programming language to be used. Now, you've done all your processes, you've done all those stages, you've defined, you've defined, you've written you've analyzed, you've performed flow charting, you've done your algorithm, you've done your dex checking. Then it's for you to actually code. It's for you to actually start coding. Coding work starts here properly. You perform your coding when you are translating whatever you've done in flowchart or in algorithm into a program. Now, this is an example from an algorithm to a flowchart, from a flowchart to a program. I come again, from an algorithm to a flowchart, from a flowchart to a program. Take note of this. It will be very difficult for you to from program to algorithm before flowchart. It is very, very wrong. So get a proper, well programmed system. You must first of all get your algorithm before you get your flowchart, and then your program. And then your program. Then next is program compilation. Are you through with your on writing your program? Are you through writing your program? What then is for you to compile the program? Now, compiling your program simply means that the program is written in high-level language and it's submitted to the computer for compilation. It is checking, okay, let us see if your program is actually correct. Compilation is still the translation of source program from its high level to its machine language. When you translate an high level to a machine language, you are performing compilation. You are performing compilation. You program that the human language to the machine language. You've performed the program compilation. You remember, I think I gave one of the classes, or 3 of the classes, compilation and interpretation. This is the class also for you to actualize that dream or that goal. Moving away from there, we'll talk about program testing and debugging. Program testing and debugging. Now, I'll be very, very direct for program testing and debugging, and it will stick into your memories. When you talk about program testing, what comes to your mind is you are checking if there are errors in the program. And debugging is you are correcting the errors that you've checked. I come again. You are checking for errors in the program. That's testing. Then debugging is you are correcting the errors that you find. So when you test something, you are testing it to see if it is okay for you to make use of. And if it is okay for you to make use of, then there's no need for debugging. But if the purpose of testing is for you to actually confirm if there are errors, next is program documentation. Any program that is well written must have a document, or you have a storage unit whereby people can always refer to if they have issues. And we have the manual and the technical um, documentation. Moving away from there, we'll talk about compiler and interpreter. Now, compiler, from what we said, when you are translating an high-level language to a machine language. You've written your program. Now you want to output your results. There's what we call the compiler. Now the compiler first of all translates from the high level, the code that you've written, down to the machine language. Now when it successfully does that, the interpreter works in it. And what does the interpreter do? The interpreter now interprets the machine language and then gives you back your answer in high level language. I come again. The compiler does the translation from high level to low level, and the low level of machine language, then the interpreter interprets back to you to see if your answer or the program you've actually written is correct. You have your high level language like your Java, like your Python, and all of that. In all, we'll do more in our next class. See you. Thanks for watching. Bye bye.